Mathematical induction, part 5.
Hello everyone, in this session we will discuss divisible problems. So these are very important. So this is the continuation of previous class. So once you see the question number 7, show that 49 power n plus 16n minus 1 is divisible by 64 for all positive integers. Let S of n is the given statement. Clearly what is the given statement? 49 power n plus 16n minus 1. So next case 1. We know that in case 1, you prove for a given statement is true at n is equals to 1. So clearly replace n by 1. So what will you get? 49 power 1 plus 16 into 1 minus 1. So which is 49 plus 16, 65 minus 1, 64. So which can be written as 64 into some value, that is 1. So clearly 64 is what? Divisible by 64, which means 64 by 64. It should be cancelled. So which means that is divisible by 64. We can say that the given statement is true for n is equals to 1. So next case 2. Case 2 is assume that n is equals to k. So means the given statement is true for n is equals to k. So clearly what will you get? 49 power k plus 16k minus 1. So which is true means, so this is also will get 64 into some value. So because of that is what? Divisible by 64. So we can take 64 into some p. Now in divisible problem we should write always first value. So remaining you can send right hand side. That is 49 power k, which is equal to 64p plus 16k becomes minus 16k, minus 1 becomes plus 1. So this is equation 1. Next, what is case 3? We prove for n is equals to k plus 1. Okay. So here replace n by k plus 1. So that is what? 49 power n. What is n here? K plus 1 plus 16 into n. Again n is what? K plus 1 minus 1. See here clearly power is what? Sum of the terms. So we can write as 49 power first term k. Again this one also 49 power, that is 49 power 1 plus multiplying with 16. 16k plus 16 minus 1. So therefore we know that 49 power k value from equation 1. What is 49 power k value? 64p minus 16k plus 1. Substitute there. 64p minus 16k plus 1 into what? 49 plus 16k plus 16 minus 1. 15. Okay. Now multiplying 49 inside of the bracket for each term. First 64p into 49. 64p into 49. Next, minus 16k into 49. Plus 49 into 1. 49 plus 16k plus 15. Now, which is a 64p into 49. See here, from the second and fourth term, there is a 16k, we can take 16k is common. Okay. So we can take minus 16k is common. Here 49. Here plus 16k is there, but here you can take minus is common. You will get opposite side, that is minus 1. 49 plus 15, 64. Again which is 64p into 49 minus 16k into 49 minus 1. 48 plus 64. Here our aim is what? We need to take common 64. Because of we show that it is divisible by 64. So observe here, in the first term there is 64. In the last term there is 64. But in the second term there is no 64. So we should make this value into 64 into something. Okay. For that we can write this 48 as 12 into 4. Okay. So here that is 64p into 49 minus 16k into 12 into 4 plus 64. Now clearly 16 into 4, 64. In the first term also 64, in the last term also 64. Clearly in each and every term contains number 64. So we can take 64 is common. And what is the remaining terms? 49p minus k into 12, that is 12k plus 64 ones. So what will you get? 64 into some value. So we can say that it is also divisible by 64. So clearly from this we can say that the given statement is true for n is equals to k plus 1. So next write case 4. So what is case 4? By principle of mathematical induction, S of n is true for n belongs to n. Okay. So next question number 8. So this is also divisible problem which is similar to previous question only. Here show that 3 into 5 power 2n plus 1 plus 2 power 3n plus 1 is divisible by what? 17. Okay. Let us consider the given statement is what? S of n. Next case 1. You prove for n is equals to 1. So means you can replace n by 1. So here replace n by 1 in equation 1. So what will you get? 3 into 5 power 2 into 1, 2 plus 1, that is 3, plus 2 power 3 into 1, 3 plus 1, 4. So which is what? 3 into 5 power 3, that is 125 plus 2 power 4, 16. So here which is 3 into 125, that is 375 plus 16. So clear which is what? 391. And how to write 391? 17 into 23. So clearly what will get? 17 into some value. So it is divisible by 17. So because of we can divide 17 into 23 with 17. Clearly 17 cancel, which means the given statement is divisible by 17. So we can say that S of n is true for n is equals to 1. So next write case 2. What is case 2? Assume that n is equals to k. So just replace n by k. Now in equation 1 replace n by what? K. That is 3 into 5 power 2 n. What is n? K plus 1 plus 2 power 3n. N is what? K. That is 3k plus 1. So which is also you will get 17 into some integer. That is 17 into p. So because of you already assumed the given statement is true for n is equals to k. Okay. Next, in this we can write always first value. We can send second term right hand side. So that is 3 into 5 power 2k plus 1 which is equals to 17p minus 2 power 3k plus 1. So this is equation 2. And what is case 3? We prove for n is equals to k plus 1. Just you can replace n by k plus 1 in equation 1. So clearly what is equation 1? 3 into 5 power 2n. What is n? K plus 1. So we should mention the bracket for k plus 1 plus 1. Next, plus 2 power 3n. Again n is what? K plus 1. That is 3 of k plus 1 plus 1. Now multiplying 2 inside of the bracket, 3 inside of the bracket. So what will you get? 3 into 5 power 2 into k, 2k, 2 into 1, 2 plus 1 plus 2 power multiplying 3, 3k plus 3 plus 1. 3k plus 3 plus 1. Okay. Here we can write 2k plus 1. Next we can write 2. Here also first you can write 3k plus 1. Next write 3. So just you can separate the terms. So because of we have 5 power 2k plus 1 value. Okay now. So that's why which can be written as 3 into 5 power. Right first and last. 2k plus 1. Next 2. This 2 is what? Power of 5. So we can write as 5 square. Again next 2 power. Right first and last. 3k plus 1. And 3 is what? Power of 2. That is 2 power 3. Clearly from equation 2, what is 3 into 5 power 2k plus 1 value? 17p minus 2 power 3k plus 1. Right, 17p minus 2 power 3k plus 1 into 5 square value 25 plus 2 power 3k plus 1 into 2 cube 8. Now multiplying 25 inside of the bracket for first term and second term, which is 17p into 25 minus 2 power 3k plus 1 into 25 plus this one 2 power 3k plus 1 into 8. Now which is 17p into 25 in both the terms. 2 power 3k plus 1 is common. Minus 2 power 3k plus 1 is common. You will get 25. Here plus is there. You can take minus is common. You will get opposite sign minus. Remaining term 8. Which is 17p into 25 minus 2 power 3k plus 1 into 25 minus 8. That is 17. Clearly in first and second term you have 17. So you can take 17 is common. So what is the remaining term? 25p minus 2 power 3k plus 1. So 17 into something. So which is also divisible by 17. So we can say that S of n is true for n is equals to k plus 1 and write case 4. Okay. If you have any doubts in this, ప్లీజ్ కామెంట్. అలాగే వీడియో నచ్చినట్లయితే లైక్ అండ్ షేర్ చేయండి. సబ్స్క్రైబ్ చేయడం మాత్రం మర్చిపోకండి. థ్యాంక్ యూ.